Alright, number 6. A stone is thrown at an angle of 30 degrees above the horizontal from the top edge of a cliff with an initial speed of 15 meters per second. A stopwatch measures the stone's trajectory time from the top of the cliff to the bottom at 5.60 seconds. What is the height of the cliff? And they said there's no air resistance, and you know the acceleration due to gravity is negative 9.81 meters per second. So right now I would like you to see if you can solve this. Those are the answer choices. I'll give you a moment. Alright, you should start by writing down your givens. So the initial velocity of the vector is 15 meters per second at 30 degrees. The time was given at 5.60 seconds, and you know the acceleration due to gravity is negative 9.81 meters per second squared. And you want to find the change in y. If you find the displacement in the y direction, then you could figure out how high that cliff is. So let's go to the next screen and look at the formulas you would use. Alright. Now, before we get to the formula, let's just do a little sketch. Make sure we're on the same page. So here's the cliff, and it's coming right off the edge of the cliff at 30 degrees at 15 meters per second. So you have in blue the x component, and you have the y component. So, what formula do you know that has initial velocity, time, and acceleration? Because you can find the initial velocity. This is not the initial velocity you need. What you need is this initial velocity going up. So how much of this 15 meters per second is going up? So you would use the sine angle times this magnitude. So this is the initial velocity going in the y direction. So here's the formula you use. The change in y is the initial velocity in the y direction, not this one, times time plus half times the acceleration time squared. So this is the displacement due to the initial velocity. This is the displacement due to the acceleration. So you can add those together and you'll find the displacement in the y direction. So let's solve this. Alright, so here's the y. We're going to plug in that initial velocity in the y direction going up. Alright, then we're going to multiply it by the time, which is 5.60 seconds, which was given. We're then going to add it to half times the acceleration, and then the time squared. I would have put a 0 there, but I ran out of space. So when we do the math, this first part is 42 meters, plus, when you do this math, it comes out to negative 153.82 meters. So that comes out to a negative 111.82 meters. Then you have to say to yourself, how many sig figs do I need? So you go all the way back and you say which one had the least number of sig figs. And it was 3. So now there's 1, 2, and then you look at that one and look to the right. Ooh, it's greater than 5. So raise it up 1, so it's a negative 112 meters. That's the displacement as it fell to the ground. It wasn't asking you that question. It was saying how high the cliff is. So what you got to do is you got to take that negative sign off, because you know the cliff doesn't go into the ground. It's not a hole. So the cliff is 112 meters tall. Let's go to the next one. Alright, number 7. Add two vectors, one going 30 meters east of north and the next one going 20 meters north of east. So what is the direction of the resultant? So here are your possible answers. See if you could figure it out right now. Take a moment. Hit pause. Alright, let's go over this. Let's do the givens first. We'll say vector number 1 is the 30 meters east of north. Vector number 2 is 20 meters north of east. So make sure you have those straight. You want to find the angle. So let's see what we do next. So to find the angle, that comes from the tangent angle formula, but we wanted an angle, not tangent angle, so we moved the tangent over by multiplying both sides by inverse tangent. Then we take the opposite over the adjacent. Now let's do a quick sketch so you don't mess up with the sides. So here is the 30 meters right here heading to the east. Here's the 20 meters heading to the north. Here is the angle you're trying to find, and this is the resultant. So the angle of this resultant coming off of the x-axis. So let's name the parts of this triangle. This is the angle, so this has to be opposite. So the 20 meters, which is the y-axis, is opposite. Now this is right next to it, so it's adjacent. So that's the x-axis. So to solve it, let's plug it in. The angle is inverse tangent of opposite over adjacent. So the inverse tangent, we just determined that the opposite is y, the adjacent is x. So let's plug in those values. Inverse tangent is 20 meters divided by 30 meters. Plug that into your calculator, see what you come up with. Alright, you should have come up with 33.69 degrees. Then you have to say to yourself, sig figs. So we started off with 3 sig figs as the least number of sig figs, so we got to end with 3. So 1, 2, 3, so your answer should have been 33.7 degrees. Let's go to the next one. Alright, number 8. A lightning bug flies at a velocity of 0.25 meters per second due west towards another lightning bug seen off in the distance. A light easterly breeze blows on the bug at a velocity of 1.25 meters per second. What is the resultant velocity of the lightning bug? So those are the possible answers. Take a moment, get out your piece of paper, see if you could solve this. Alright, let's do a sketch. That's the easiest way to look at this. So we're going to add the vectors together. So we're going to say the bug is number 1 vector, the breeze is number 2. So the bug is going to the west at 0.25 meters per second. So we draw the vector. Now the tricky part of this problem is the breeze. Did you remember that we name wind based on where it's coming from? Alright, not where it's going, where it's coming from. So the easterly breeze is coming from the east and going to the west. So we're going to use number 2 vector right here. We add it to the head of the last one. Here's the tail of the blue one. And we draw it in. So the total resulting velocity will be vector 2 plus vector 1. So it's a negative 1.25 meters per second because it's going to the west, plus a negative 0.25 meters per second because it's going to the west. When you add that up, it's negative 1.5 meters per second, or you could have said 1.50 meters per second west. Check the sig figs. Did I do it correctly? Are there 3 sig figs? Go back to the original problem and count. Alright, let's go to the next one. Alright, number 9. A plane flies from city A to city B. City B is 1,540 kilometers west and 1,160 kilometers south of city A. What is the total displacement of the plane? Watch your sig figs for this one. So those are your choices. See if you could sketch this. See if you could figure this out using the Pythagorean Theorem. Alright, hopefully your sketch looks something like this. So we're going to start at city A, and we're going to go west 1,540 kilometers. Then we're going to go south 1,160 kilometers. So we're going to draw the resultant from where we began at A to where we're ending, which is going to be B down there. So this dotted line represents the displacement from A to B. So you already have a right triangle, so you don't have to find any components. So you can just jump into the Pythagorean Theorem, which is c squared equals a squared plus b squared. Then you want to get rid of this square, so take the square root of both sides. So now you have c equals the square root of a squared plus b squared. Plug in the information. Alright, if you put negative signs, that's okay, because it's going to the west, which is negative, and it's going down, which is negative, to the south. So the negative signs will be eliminated by the squaring anyway. So when you do this math, it comes out to 1,928 kilometers, and then guess what you got to go figure out? What the sig figs were with what you started with. So based on this answer, how many sig figs were there? I hope you said 3. 1, 2, 3. That 0 is there for position. Now, this is not the final answer. This is the magnitude of this. So from here to there, it's 1,930 kilometers, but you still got to find this angle right here. So let's go to the next formula we're going to use. Once again, angle equals inverse tangent opposite over adjacent. Now, the opposite was a negative 1,160 kilometers. The adjacent was negative 1,540 kilometers. And you multiply that by the inverse tangent. It comes out to 36.9 degrees south of west. But I told you, I like going all the way from the positive x-axis, which is 0. We could come all the way around and to this line, which is at 36.9 degrees south, and this is the west, south of west. So when we do this, this is 180 degrees right here, and we add in the 36.9, so it comes out to 216.9 degrees, or you could write down 217 degrees based on sig figs. So it's 217 degrees from this x-axis. So this was always our standard. Alright, I hope you got that. Let's go to the next one. Alright, number 10. A hiker walks 4.5 kilometers at an angle of 45 degrees north of west. Then the hiker walks 4.5 kilometers south. What is the magnitude of the hiker's total displacement? So those are the possible answers. Pause right now and see if you can find this. I recommend sketching it and then using Pythagorean Theorem once you find the x and y components of the first vector. Alright, hopefully you're not saying, oh my god, look at all that. So let's just look at this piecemeal. So here's the sketch. Here's our original vector. It's at 45 degrees and it's going north of west. And that represents 4.5 kilometers. Then here's our second vector, the one in the blue. It's going due south, once again, 4.5 kilometers. So what you want to find is the resultant. So where we started from, over here with the first one, and we're going to end over here. So this green one, the line from here to here, is going to be the resultant. So once you look at this, this right here is not a right triangle. So you've got to make this into a right triangle. So here's the y component and here's the x component. You could have easily said here's the x component, here's the y. In this one it would be the same because it's 45 degrees. Alright, so at 45 degrees it's hard to go wrong. So I'm going to just use this one. And since I know this is 45 degrees and from here to here is 90, then I know this angle is 45 degrees. Now the resultant in the x direction is going to be x1. This x we're going to find from this component of the first vector. The resultant in the y direction is going to be y1, the y component of the first vector, plus y2, the second vector only has a y component. So if we want to find x1, so we can find this total resultant in the x direction, we're going to take x1 equals, and then you got to make a decision. Do I use sine or cosine? So x is opposite. So that's so, because its sine angle is opposite over hypotenuse. So we're going to use sine times 45 degrees times 4.5 kilometers. That comes out to be 3.18 kilometers, but that's going west, so make sure that negative sign is there. Alright, the y component, the y is the adjacent, so you're going to use ka. Cosine angle is adjacent over hypotenuse. So there's the adjacent, that's what we're going to find. So we're going to say y1 is the cosine 45 degrees times 4.5 kilometers, which is going to be 3.18 kilometers. But this is going up, so it's positive. So let's find these right here. Over here, I'm going to do the work. Alright, the total x direction resultant is going to be this. Negative 3.18 kilometers. Okay? Now, we have two y components. We have y1 and y2, so you better be careful of the signs. So I'm going to take the 3.81 kilometers, which is y1, right there, and I'm going to add y2, which is negative. It's going down. It's going south. So it's a negative 4.50 kilometers. When I add those two together, it comes out to be a negative 1.32 kilometers. So right now we now have the x and the y components for a right triangle. So what are we going to use next? Think about it. I hope you said Pythagorean Theorem. So the resultant is, instead of putting a and b squared, we're going to say rx squared plus ry squared, which is a and b squared. So we plug in the values we just found, and that comes out to be 3.44 kilometers. But if you go back to the original problem, Mr. D must have made a mistake. There's no 3.44 kilometers as a possible answer. Well, that's correct. So I just pushed it a little. I pulled something out of chapter 1. Box method, conversions. You can never forget those. So I gave you some answers in inches and yards. So let's check the inch first, see if the correct answer is there. So I'm going to take the 3.44 kilometers, which is the resultant, and I want to change that into inches. So I'm going to go kilometers to centimeters. So you put a 1 in front of the kilometer because it's bigger. You want the kilometer down here so you can cancel it out with this numerator kilometer. Then you have to say, how many centimeters are there? Ooh, here we go, Bunnyhop Method. King Henry died Monday drinking chocolate milk. So let's hop over. 1, 2, 3, 4, 5. So that's 10 times 10 times 10 times 10 times 10, so that's 1 and 5 zeros. So here we go, 100,000. So there's 100,000 centimeters in a kilometer. So you cancel out kilometers. So now your answer would be in centimeters, but let's change it to inches. So put the centimeter down here. Alright, and so it's 1 inch. When you want to change it to inches, so it has to be up here, is divided by 2.54 centimeters. So cancel out the centimeters. So do the math. 3.44 times 100,000 times 1 divided by 1 times 2.54. So let's see if you got that right. So the answer comes out to be some huge number. 135,433 inches. But that number's not there. But there's something with scientific notation. So let's move the decimal over. 1, 2, 3, 4, 5. So then it's 10 to the 5th power. And it's 1.35 times 10 to the 5th power inches, which is the answer. Yes, I brought something up from chapter 1. You never can forget what you learned in the past. Physics will keep bringing it up, especially in this book. All right, let's go to the next one.